Happy coding.
Hey there, this is Kevin from Happy Coding, and I am here to work through a Leetcode problem, in this case, the search insert position problem. I am going to approach this a little bit differently than a lot of other like Leetcode videos go. I'm not going to just dive right into some clever solution. I am going to work through this as if I am in an interview environment. So I'm going to talk about the problem, how I would frame it as an interviewer, and I'm going to talk about the problem, how I would approach it as a candidate, as someone going through the interview process. So I'm going to kind of have that back and forth and convert like the Leetcode interface into the like interviewing environment. So here we go. The problem itself, and again, I'm going to try to translate into an interview. So if I'm in an interview, the interviewer might give me the problem of, given a array of integers and a target value, return the index of the target, or if the target is not found, return the index where it would be if it was inserted into the array. So that might be all my interviewer gives me. Leetcode itself gives you a bunch of other information down here. I'm not going to scroll down just yet because in an interview, as a candidate, it's my job to like tease that out. So if I'm sitting there in the interview, I might start to ask, first off, like, can you give me an example input and output? If my interviewer hasn't given that to me already, that's a pretty reasonable like first question to ask. So Leetcode just kind of gives those to you, and it's tempting to just kind of, scroll automatically to them. But I would encourage you to think in terms of what questions you would ask in an interview. So I've asked for an input and output, and here they are. Here are a few. So if the array is 1, 3, 5, 6, and my target is 5, then I return the index of 5. So in that case, 0, 1, 2. Here's the index of 5. It's 2, so I return 2. In this case, the array is 1, 3, 5, 6. Actually, it's the same for all of these examples, 1, 3, 5, 6, and my target is 2. Now, 2 is not in the array, so I am returning the index that 2 would be in the array if it was in there. So 0, 1, I see that the element at index 1 is a 3, so 2 would go between 1 and 3, which means that 2 would be at index 1, then 3 would go to index 2, 5 would go to index 3, and so on and so forth. So that's a case of the target not being in the array to begin with. And then last example that it gives me here, which my interviewer would be giving me, is if the target is 7. So in this case, it's all the way off to the right edge of the array. So 0, 1, 2, 3, 7 would come after 6. So my output is index 4, which because of 0 indexing is actually the 5th index. So it would go like after the 6 here. So those are some example inputs and outputs. And again, in an interview environment, I might have to tease those out with my interviewer. The sort of next phase that I would work through is thinking about like the boundaries of the problem. So in other words, corner cases. So what kinds of input can I get? For example, do I always know that the array is sorted, or will I have to sort it myself? Again, your interviewer might have a different answer depending on who they are and what the question is. But in this case, the array is always sorted. So I'm filing that away in my brain as something that I might be able to use in my solution. Other corner cases might be, can the array contain duplicates? So can I have like 0, 1, 1, 1, 1, 1, 2, 3, 4? Can I have the same value multiple times? And again, that's a question that you should ask your interviewer. But in this case, the answer is no. The integers will always be unique or distinct, and it will not contain repeats. Okay, so other corner cases, I'm just kind of thinking out loud, saying these to my interviewer, like, can the array be empty? Do I have to handle that case? And in that case, like, what would be, the answer? Can the array be null, for example? And I think Leetcode probably gives these to you. Yeah, okay. So the array always has at least one value, looks like. Can the elements be negative? Apparently they can be negative. So I might have to keep that in mind as well. And the target itself, can that be like really small, really big, all that kind of stuff. So those are some corner cases that I might think about or just say out loud. And I might even say, well, if I'm writing this function, I might want to check if nums is null and maybe throw like a null pointer exception or an illegal argument exception. Do you want me to code that up, or would you rather I focus on the logic of the problem? Check in with your interviewer. Even by asking the question, you have shown them that you are thinking through the corner cases and that you know how to handle that kind of like exceptional case. And often your interviewer will say, you know what, no, good enough to mention it. Let's move on. So you don't have to spend a ton of time like thinking through it, but naming it is really helpful or really valuable. Okay, so I've got sort of I understand the problem. I've gotten some example input, some example output. I've talked through corner cases, and I know the sort of format of the of the of the input that I'm getting and the format of the output that I am giving. In a real coding environment, I wouldn't have this like handy boilerplate. So I would have to come up with the like function definition myself. I would say, so I think I'm going to return an int here. I'm going to take an array of numbers and I'm going to take an int target. You'd have to, code that all up by yourself, but Leetcode gives it for you sort of automatically here. Okay, so now in the interview environment, I am at a point where I want to describe what I'm thinking. I want to describe my approach at a high level. So just for starters, I am going to straight up ignore this requirement. I'm going to get something working, maybe like kind of brute forcey, and then go from there, try to improve and iterate, because that is how I would do it in an interview environment as well. So what I'm thinking, since the array is sorted, I can maybe have a for loop that starts at index 0 and goes, iterates by 1, 0, 1, 2, 3, 4, all the way up to the end of the array. So iterate over every single element in the array. And if I find an element that is equal to the target, then I know that I should return that index. And if I find an element that is greater than my element, then I know that I have not found my element. And so my element is not in the array, and I should be inserting it at this index. So at whatever index I find a value that is greater than my current element. So I just described my approach at a really high level. I have not written any code yet. But I'm checking in with my interviewer. I'm saying, here's what I'm thinking at a high level. Does that sound reasonable? Is that what you're looking for? And the interviewer will often say, yep, that sounds good. Maybe start coding that up. Or they'll maybe push back and say, that might work, but is there a way that you can do it without iterating over the entire array? Is there some kind of other algorithm that you might use that is not linear, is maybe sublinear, or in this case, O of log n. So that's kind of a hint to me that maybe I should think a little bit more about some other approaches. Or if I'm kind of running out of time or feeling paranoid, I might say, you know what, I'm going to get started with the brute force and I'm going to come back and look for ways to improve it later. For me, I'd rather have a brute force approach that works instead of trying to struggle, like trying to remember some algorithm that I don't quite understand and ending up with like broken code or like just something that doesn't work. So I would encourage you to like get started with a brute force solution if something else doesn't come to you pretty quickly. So I'm going to get started on the brute force solution, and I'm going to come back and maybe think about other ways of improving it. So what did I say? I said I'm going to have a for loop. So for, that's funny. I'm so used to JavaScript, I almost typed let here, but whatever. Java is int I equals 0. Whoops, don't know how that happened. Int I equals 0, I is less than nums dot length. I think that's a field on an array, and I plus plus, and curly braces, and give myself some white space. So I'm iterating over every element in my array, or every index in my array. And maybe I'll say like int, I don't know, value equals nums I. So I'm getting the value at my index. And what do I want to do? I want to first check if my value equals my target, then I want to return I. So I've handled the case where my target is in my array. So I've handled like this case here. But what I haven't handled is, well, both of these cases actually. So target is 2, 1, 3, 5, 6. So I'm going to iterate over my for loop. This if statement will never be triggered, and I'll never return anything. Actually, this is going to be a compiler error actually. So what do I want to do if I have not found my value? Well, let me look at this input, and in an interview environment, maybe I would have typed out these inputs and outputs like in a comment or something. So 1, 3, 5, 6, because I wouldn't have this the Leetcode interface. I wouldn't have like a run button or anything. So I might have to write this down as my interviewer is telling me. So here's how it might look in a real interview environment, which might just be a comment that I've written. Anyway, either way, whether you're looking at Leetcode or your own comment, I'm thinking through this case. So my target is 2. So I'm looping over and I see index 0 is 1. So that's less than my target. So I know I need to keep going because my array is sorted. I know that it's going to be like after that index. But when I get to 3, I know that I've reached a point where I have not found my value, my target, but I have found something that would come after it. So the first time I encounter a value that is greater than my target, I need to return that index actually. So in this case, since 3 is greater than 2 and 2 was not in the array, I return the index of 3, which in this case is 1. So I could say like, maybe I'll have another one like if value is greater than target, then I also return I. So actually this, I can maybe clean up my code real quick here. So this is actually greater than or equal to, since it's the same logic. So I'm going to just get rid of that. So I have found, or I've thought through the case where my target is not in the array and it's sort of like, it belongs in the middle of the array somewhere. I don't think I've handled this case because at no point am I going to find a value that is greater than or equal to 7. So I'm going to exit this whole loop. And in this case, I think I want to put it at the end of the array. So in this case, I want to return nums.length, I think. Again, I have totally ignored one of Leetcode's requirements here, but that's okay. I'm going to come back to that. Because I'm thinking about this in terms of a job interview, they likely wouldn't start with this requirement. They'd likely just ask you to do it generally, and then they'll come back and say, "Ooh, can you improve that?" So that's what I'm going to do. Anyway, I think this will work if I've coded everything right, but probably there's a syntax error or something. So let me just hit run and see what happens. So, okay, the example cases, these 3 that they give you, seem to work. So let me hit the submit button and see what happens. I'm sort of guessing that I'll like have it's going to take too long or something, but yeah, actually, no. Okay, cool. That's all right. Nice. All right, that's a little bit surprising, but okay. I would have maybe expected this to run out of time. I'm a little suspicious that this is 0. That doesn't feel right, but okay, whatever. Either way, I am feeling pretty good if I'm in an interview environment. I have something that works. I would have run through a few examples in my like just verbally, because I wouldn't have a run button or a submit button in an interview environment. But if I've worked through a couple examples sort of line by line, and I've convinced myself that my code is doing the right thing, I'm feeling pretty good, honestly. But no interviewer is going to say, cool, you answered the question. Now let's sit here in awkward silence for the next 20 minutes. That will never happen. There will always be a follow-up question. And in this case, the follow-up question is, well, it's a pretty common follow-up question. And that is, first, what is the runtime complexity of your approach? Not every interviewer will ask it in those exact terms. Some might just say, like, are there any ways you might improve it? But if they are looking for the big O notation, then in this case, I am looping over the input over nums and doing constant time stuff, constant time stuff, constant time stuff. So in this case, this is linear, or big O of n. That's the complexity of this solution. So my interviewer might say, okay, so if that's O of n, is there any way that you could improve on that? And so now it's my job to, as the candidate, as the interviewee, to think about like the nature of the problem, the like scope of the problem that I outlined at the very beginning, and any like properties of the input, or any data structures or algorithms that I can think of that might apply to this problem, and try to get better than what I have already, which is iterating over every single element in the array. So just thinking out loud, and this is what I would say in an interview as well. I'm just thinking out loud. I'm thinking if there's anything in the language that I might be able to use, or any algorithm that I might be able to use. And so I know that I have a sorted array, and I know that, maybe I'm looking for a log of n runtime. And so those two things are hopefully setting off some like spidey sense if you've taken a data structures and algorithms class, because one of the most famous algorithms of all time probably is binary search, which takes, either it can be like a tree, but a sorted array, and runs in log of n time. So this is feeling like a binary search problem. And so what I might do is implement binary search to either find the element or the index. I'm kind of fuzzy on that one, but that's kind of the inkling that I have. And I would say that to my interviewer as well. Real quick, I'll also just say like another thing that I would be doing at this like phase of the problem, actually, at any phase of the problem, is thinking about like shortcuts I might take, like language specific things. So I have a vague recollection that Java has like an arrays class, and I think that arrays class has a binary search function. So I'm actually just kind of curious. I wouldn't be able to look this up in an interview environment, but I'm using Leetcode, so let's just take a trip down this rabbit hole real quick, and see if this gets me anything. So int array, int key. So this feels pretty similar to what we're looking at. So search is the specified array of ints. Yep, must be sorted. Yep. If it is, yeah, okay. If the array contains blah, 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 okay. So returns index if it is contained, otherwise it returns some like, I don't know, some negative value of the insertion point. Okay. So I could maybe just use this, and maybe I'll try that just for funsies, honestly. Likely, if I was trying to bring this up in an interview, my interviewer might say, okay, you can try that as a, just to get something working. But likely, as a very quick follow-up, they'll say, okay, what if you couldn't use that? So it's good to name these kinds of language features that could make your life easier, but don't count on them. I am just kind of curious. I am going to just try this out a little bit. So it's what? Arrays dot binary search takes an array and a value. So instead of all of this, what I might be able to do is int, what does this return? Index. So maybe I'll just say index equals arrays dot binary search nums target. And I think if index is greater than or equal to 0, then I just want to return the index. And I'm doing this because I believe, I haven't actually tried this yet, but just from what I was reading over on that other page, arrays.binary search returns a negative value if the element was not in the array. So it's like indicating to you this wasn't in the array, but if it was, here's where you would put it, which is the exact problem that we're trying to solve. So it's going to be negative if it was not found. So negative insertion point -1. Let me actually just copy that over because I'm going to need to think about this. And otherwise, I want to do some math, and I want to say return what? I'm going to return some index, but some math. So negative insertion point -1. So if I make this negative index +1, is that right? We're going to find out. Okay, so I am basically cheating here by using the arrays.binary search function. Again, in an interview environment, I could probably name, hey, I think this function would work, but your interviewer probably won't let you. But I don't know, I'm going to try it just for fun. And all right, I've got my wrong answer. Cool. What do I want? Target equals to output 3. Okay, so maybe my +1 is not correct. So maybe I just need to get rid of this +1. So expected 1. Maybe this needs to be a -1, actually. I will admit that right now I'm kind of shotgun debugging because, I don't know, in an interview, I probably wouldn't use this approach. This is kind of just out of my own curiosity. Okay, so the gimme's passed. Let's just submit this and see what happens. And okay, I am pretty suspicious that the runtime is 0. I think Leetcode might be bugging out, but I'll take it. So this works, and if I can code this up really quickly in an interview, I get some points for being familiar with the language, and my interviewer would probably, note that in their notes. But again, your interviewer is never going to say, okay, great job, you're done. Let's just sit here in silence for 20 more minutes. They'll always have a follow-up, and in this case, that follow-up would be, okay, what if you couldn't use that arrays.binary search function? So now I am back to implementing binary search myself. So alas, my cheating did not pay off, and I still have to code something myself. Okay, so I haven't really practiced binary search in many moons, but let me think through this. So the way binary search works is it's sort of based on the underlying structure of a sorted array. So let's say I have a big old array, and it's like 0, 1, 2, ... lots of things all the way up to, I don't know, like 999, 1000. And let's say I wanted to find a specific number. Let's say I wanted to find, I don't know, 600. I wanted to find the index of 600. I don't know exactly what these numbers are. So like it could be that they jump forward. It could go straight from 7 to 99. So I can't just go index 600 because I don't know for a fact that that's where it's going to be. But what I can do, and maybe this is even like actually a really huge number. And so I don't know exactly where in the array 600 will be. So a brute force way to find that 600 is actually what I did right here, is I just start at the beginning and I say, is it at the first index? Is it at the second index? Is it at the third index? Is it at the fourth index? Until I find the index, or I find something that is bigger than that value. So the way binary search works is every step of the algorithm, it splits the search space in half. So in this case, it would start at like index 500. So let's say that's 500. And I'm looking for 600 again. So I say I say I start out with the whole array, and then I find the middle value of that array. In this case, let's just say it's 500. I look at the 500 and I say, okay, the number I'm looking for, 600. Is that less than 500 or is that greater than 500 or is it equal to 500? If it's equal, then I just return that center index. But if my value is less than the center value, then I repeat that entire process only with the left half of the array. So then I find like the midpoint of that half and repeat. In this case, since 600 is greater than 500, I will repeat the process with the right half. And I'd say, okay, so 500, and I said like what, there's 1,000 elements in this. So 500, and this is like index 1,000. I find the center of that, which will probably be like index 750 or so. And I look at what value is there, and I iterate and I cut it in half every time. I cut the search space in half every time, which gives me that log n runtime because I'm splitting it in half each step of the algorithm. So anyway, I will admit that I am stalling because I don't remember off the top of my head how to do binary search, but this should be fun. So I think what I need to do is I need a left index and a right index, and then I need to calculate like a center index and then do exactly what I just described, where I'm moving either the left index or the right index based on the result of my comparison. So this is getting a little messy because I'm just commenting out the code, but let's just dive in. So I'm going to say like int left index equals, and at first it's going to be 0, and int right index equals, it's going to be nums.length. And here again, it's kind of a Spidey sense kind of pattern matching deal. Right now I am trying to look forward to off by 1 errors. So I'm like, does this need to be nums.length or is it nums.length -1? And I think it's -1, but in an interview environment, I would just name that. I would say, you know what, I would maybe come back to this later because I think there might be an off by 1 error, but just to get something working, I'm going to leave it like this for now and come back to it if I once I start debugging. So, okay, I've got my left index and I've got my right index. So now I need some kind of like driving component, and I could maybe use recursion if I'm feeling fancy, but I'm not feeling fancy. So I'm going to do it sort of just the iterative way. So I think I need maybe like a while loop, and I need to continue looking in my array while my left index is less than my right index, or maybe less than or equal to. So they're going to get closer and closer together. And if there's ever a point where they are the same, then either I have found my element, hopefully, or my element is not in my array and I have found the index that my element would be in. I think. We're going to find out. So I've got my while loop, and in here I need to first calculate the center index. So int center index equals what? Left index plus right index divided by 2. So this is finding the midway point between my left index and my right index. So if this is like 500 and 1,000, 500 plus 1,000 is 1,500 divided by 2 is 750. 750 is right between 500 and 1,000. So this is my center index, and I need my value, which is going to be kind of similar to what I did here. Int value equals nums of center index. And then what do I want to do? I want to check if my value equals my target. And in that case, I have found my target, so I'm going to return center index. And then I need to, so if that hasn't happened, if this if statement is not evaluated to true, if value is not equal to target, it's either less than my target or greater than my target. So actually I am going to switch the order of these. That might sound like I'm being kind of picky and pedantic, but I think this will help me write my else if statement. So else if my target is less than my value, then I know that my target is to the left of where I am searching. So it's to the left of my center index. So I need to change my right index. My right index becomes my center index, I think -1, right? Because I know that it's not my center index, so I need to look to the left of it, not including the element that I just eliminated. So I have split my search space in two by moving my right index to the center so that I now look on that left side. And then otherwise, else if target is greater than value, I could have probably gotten away with just an else here because this is the only other thing that can be true, but whatever, this makes it a little bit more explicit and maybe a little bit easier to follow. I'm going to change my left index to be my center index +1. Okay, so this while loop, I think, is implementing binary search. And maybe I should run through an example. So let's see. So at this point, I'm pretty tempted to just hit that run button and see what happens. But in an interviewing environment, I won't have a run button. I won't have a submit button. I won't have a compiler. I'll be alone in the world. So I have to rely on my own brain to do debugging, and this will feel tedious. It's not super fun, but you will have to do it in an interview. So let's just do it. Let's say 1, 3, 5, 6. Let's just work through this this example. So my left index starts at 0. Okay, so I'm going to maybe just have a comment here just to keep track of it. 0. And my right index starts as nums.length -1. So in this case, 1, 2, 3, 4 starts as 3. Okay, so my left index is 0, my right index is 3. While left index is less than or equal to right index, 0 is less than or equal to 3. Cool. Center index equals left index plus right index. So 0 plus 3 divided by 2 is 1.5. Converted to an int is 1. So I'm going to say this is 1. Value equals nums of 1. So in this case, that's 3. And my target is 5. So if 5 equals 3, it doesn't. If 5 is less than 3, it's not. Else if, and here's a great example of why reading through my code line by line is so necessary, because this is a mistake. This should be greater than. So I have debugged my code without my interviewer being like, "Ooh, I think you might have a mistake on that line." Like, I am driving that conversation, that process, by just walking through my code line by line. And as long as you fix that kind of thing, it's no problem. In fact, that's actually a really good sign that the candidate can work through their code, talk through their code, and fix their errors themselves. That's actually better than, I don't want to say better than not getting it wrong in the first place, but it's a good signal if you're fixing your problems along the way. Anyway, target is what? Target is 5 is greater than 3. So my left index becomes center index, which was 1 plus 1. So center index becomes, or left index becomes 2. So 2, and my right index stays the same. So now I'm back at the top of my while loop. While left index is less than or equal to right index. So while 2 is less than or equal to 3, that's true. So when I enter my while loop, center index equals 2 plus 3, which is 5, divided by 2 is 2.5, truncated is 2. And then my value equals nums at 2, so 0, 1, 2. So this is 5. And is 5 equal to 5? It is. So I return center index, I return 2, and that is the correct output for this case. So I'm feeling pretty good about that. However, I have not actually handled the cases where it's not found. So in this case, my algorithm here, my while loop, my binary search here, it's looking for a 2, and it's going to loop all the way through until eventually left index will equal right index, and this while loop will exit, which means that the indexes have converged onto, like, here's where we think it should be. And at that point, I need to return left index, I think. Again, I should, if this was a real interviewing environment, what I should do is step through these examples. I would do that out loud exactly how I just did it, but because I am using Leetcode and because it is really tedious to sit here and watch me step through my code, I'm just going to hit the run button. And okay, cool. Shockingly enough, that works with the gimmies. I'm still suspicious of this 0, but it's fine. Let's hit submit and see what happens. Huzzah. All right, cool. So my binary search approach works. I'm just gonna ignore that commented out code. Going to maybe get rid of some of this because it's annoying me. But in general, my solution uses binary search to split the search space in half each time, which means that my the algorithmic complexity of this solution is log n. It's O of log of n, because every single step of the way, I am splitting the number of steps I need to do in half. So this is getting pretty close to optimal. I would be really surprised if there's a better way to do this. I'm sure there's some weird, clever algorithmic thing to do, but if I'm in an interview, I'm feeling really good about this this answer. Okay, so that is like the solution, or at least a solution to this Leetcode problem. I'm going to go back to like an interview environment, and what would happen now, like I've said a couple times now, your interviewer is never going to be like, hey, great job, you finished it, let's just sit here in silence for 20 minutes. There will always be a follow-up. So in this case, I don't know, I didn't come up with any follow-ups ahead of time, but just thinking about it, it could be like, what if this could contain duplicates, for example? How does that change your algorithm? Or what if the array was so big that it wasn't just one function call? Maybe it was like a stream or something. How would you do it then? Or maybe it would be something like, I don't know, what if these were strings instead of integers? I don't know if that actually changes anything. I'm just thinking out loud. There would be a follow-up though. So as you are working through this kind of problem, just think to yourself about ways that you might extend it as an interviewer. If you were, in a room with somebody who finished it in 10 minutes, what would you fill that time with? Because that's honestly what your interviewer is doing. Okay, I think that's everything that I wanted to do here. So I solved the search insert position first with like a brute force approach, just using a for loop. Then I tried to cheat basically by using an existing function in the Java API. And then finally, I implemented it myself using good old-fashioned algorithms that I learned many, many years ago. And this is a pretty standard flow of how a job interview might go. So hope that was helpful. I'll see you in the next one. And until then, happy interviewing.